Welcome to Chapter 9. Chapter 9, Polygons. So we're at the threshold of something entirely new, although it will seem oddly familiar. Remember three-sided shapes, triangles, four-sided shapes, quadrilaterals. Well, polygons, 5 and above. Now, a triangle is a polygon, so is a quadrilateral. But, we're looking at lesson 58 and the following lessons at polygons with more sides, okay? So, pentagons and hexagons. Pentagon 5, hexagon 6. You'll learn about up to 10 sides. And so, here are the names. A heptagon is an 8, octagon 9, octagon is 8. 7-sided is heptagon, sorry I'm getting mixed up. 9-sided is a nonagon, okay? And the list is completed by a decagon. So you get the idea. The roots give a hint. The whole list is here. 3 triangle, 4 quadrilateral, and so on down to the decagon. Okay, so just make sure you just remember what these are. It just takes a few seconds. Hectagon, heptagon, hexagon, pentagon, so that you know. And this list on page 370 gives it to you in case you need. Okay. Now, interesting thing here is the number. Convex and concave. I didn't want to miss that. Note that these are convex. Okay, convex means that the sides are pushing outward. Okay, as opposed to concave, where the sides could be pushing inward. So you could have F, G, H, and then the I could be here, the J could be here, and you could have a sort of shape that has not only outward but also inward. So that would be concave. The way to remember convex and concave, convex includes X, and X, from your Latin, always means coming out of. Concave, think of a cave, inward, okay, something with a hole, something where you're going inward, okay, so that's just a quick mnemonic to remember the difference between a concave shape and a convex shape. Now you're told here that you'll only be looking at polygons that have convex shapes. A lot of the things you're going to learn fall apart if you start looking at polygons with concave shapes. Okay, so this is limited to convex. The other thing that you look at here in this chapter are the diagonals. Remember, triangles had no diagonals, quadrilaterals had 2, and the different shapes, depending on their sides, the number of sides they have a different number of diagonals. The pentagon has exactly 5 diagonals. A hexagon has 9. So there is a steady progression upward, okay? And as the number of sides increases, there must be some semi-exponential increase in the number of diagonals. Okay, hexagonal 6-sided. The 7-sided, the heptagon, I'm sure has more than 9, maybe many times more. So as the number of sides increases, the number of diagonals increases even more quickly. Just think of something like a decagon. If it were to start here, there are how many? H, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 sides and 10 vertices. These would not be, but there'd be 7 diagonals emanating from H, and 7 emanating from I, and so on. So it quickly goes. The numbers quickly rise. Okay. Now, as a footnote, because it's a footnote, I don't imagine you'll be focusing on it, but there is a formula. The number of sides minus 3 times the number of sides divided by 2 gives the number of diagonals. So a 10-sided shape should be 10 times 70. So 10 minus 3 is 7 times 10, 70 divided by 2, there should be 35 diagonals. And so this formula allows you to calculate quickly how many diagonals there would be. Very interesting, okay, for someone interested in graphics. Intriguing. Now, and then you're on to your practice set. So really this chapter is very simple. It's simply the names of different polygons, 5 and above, and the notion of convexity and concavity, and just knowing that you're you're focusing on convexity. Believe me, the word convex is something that's going to come up in the future. Maybe not in this book, but certainly in the future. I saw it a lot in mathematics. And just a quick note on diagonals. So good, no proofs, no headbanging stuff, and you're straight into your problem sets and your practice set. So good luck. Bye.